Hello guys, welcome to my YouTube channel CCNA Day 6. I am Muhammad Ayub. I am your trainer for this entire series. Today we are going to see the dynamic routing. In the dynamic routing OSPF we are going to see. In the last video we have seen the EIGRP, how to configure the EIGRP. We have seen in the last video. So now we are going to learn the OSPF. In the dynamic routing we are going to learn the OSPF. So first we'll read the theory. OSPF stands for Open Shortest Path First or Link State Protocol. We can say the Link State Protocol, so we can call as OSPF. So first point is Link State Protocol, and the second point is Open Standard Protocol, and third it's use Dijkstra algorithm, shortest path first. This is the scientist of Dijkstra who has invented this OSPF protocol. And the fourth one is classless routing protocol. It supports the classless routing also. And the fifth point is 224.0.0.5. Sixth point is trigger update immediates, hello packets and every 10 seconds. In the EIGRP we have seen that hello packets are sent every 5 seconds. Now in OSPF the hello packets are sent every 10 seconds and message distance is 110. The OSPF AD value is 110. Okay, and the metric cost, this is the formula. Unlimited hub counts. In the OSPF the hub counts are unlimited. That means unlimited routers we can connect in the network. And that interval time is 40 seconds. Successor of RIP. Updates are sent through multicast IP address 224.0.0.5. Designs with multiple areas. One area has to be designed as a area 0. Area 0 is called as backbone area. OSPF table. It also contains three tables. First one is neighbor table. Neighbor table contains information about the directly connected network of OSPF neighbors. And the second table is database table. Database table contains information about the entire view of the topology with respect to each other. And the third table is routing table. Routing table contains its information about the best path. This is the syntax of OSPF. IP routing, route over OSPF, process ID. Process ID starts from 1 to 65,535, same as AS number which has used in the EIGR. And the network directly connected network ID and wildcard mask. We'll see what is the wildcard mask and the area ID. How to calculate the wildcard mask? I will show you the practical here. So actually, for every IP address there is a subnet mask, right? For a class A, subnet mask is what? 255.0.0.0. In the class B, 255.255.0.0. and the class C, 255.255.255.0. To understand the wildcard mask, how to calculate? It's a very simple, guys. See this wildcard mask default SNM bit number. Say for example, in the class A, the one network portion is there, right? So 255 we are using in the network portion. So we have to vice versa the IP address of the subnet mask of the class A. Wherever that 255 is there, we have to just take as a 0, and rest of the 0 we have to take the 255. That's it. That is a wildcard mask. How to calculate the wildcard mask? It's a very simple. It's a very simple way. This is the formula. Minus 255 to 0 minus 255 to 255 to 255. We will get this. So we need to minus from the subnet mask. Just assume that whenever you find the 255 is there, right? So in the 255 you just take as a 0, and rest of the 0 you have to take the 255. This is a simple way to calculate the wildcard mask. Okay, and this is also the theory. Link state protocol, open standard protocol, we have already read this, and some more points is here in this theory. The size of the scale of the large network hierarchy network design using area 0. Area 0 has a design to as area. One area has to be designed as area 0. Area 0 is called as a backbone area. OSPF stands updates using LSA link state administrator when there is a change to one its links. LSA are additionally refreshed every 30 minutes. Updates are sent through multicast IP address 224.0.0.5 and 224.0.0.6. Support trigger update and incremental update. Allow packets and every 10 seconds. Administrative distance is 110. This is the formula. And this is the formula. And this router ID. What is router ID? See this. Router ID is used to identify the router. The highest IP assigned to an active physical interface is the router ID. If logical interface is configured, then the highest IP assigned to the logical interface loopback is the router ID. So OSPF table, it contains three tables. We have already read this, and wildcard mask we have already calculated. This is our today's practical. This is the diagram which we have to configure in our practicals. Okay. Okay. So based on this diagram, we have to configure our today's practical. So go to the we are going to the practicals. Dynamic routing. Dynamic routing. We are going to learn the OSPF. Open shortest path first. It is also called as open shortest path first. First we'll see the IP address is based on our practicals or not. See, we are not changing anything because to better understand, we are not changing anything. The IP address are same in the like OSPF and static routing, and we have all the three branches same in the like all the practicals. So just we have to configure our protocol only. For routing protocol only, we have to just configure. Whereas the rest of this we have already same in all the practicals. See this. The Chennai branch LAN IP is 168.1.1 and the Chennai E0 IP address is 168.1.1 and Chennai S0 serial interface IP address is 170.16.0.1. It is the same as the EIGRP only. We have just configure our routing protocol. See this. From here we have to configure for all the branches. So for that we have to make it as a default in every router in every branches because we have configure all the LAN network, right? So we have to just remove the protocol from the router. Show running config. Okay, see this. The IP address is same as per our nodes only. So remember guys, based on the nodes only, we have to do the practicals so that you will get the proper output. Okay, clear? So let me remove the EIGRP protocol from here. So see this, we have to remove this EIGRP protocol from all the branches. Why? Because we have copy all the entire practicals, right? So how to remove the routing protocol of EIGRP, I will show you. So for this, how to remove config T IP routing router. No IP route we are using in the previous classes, right? So here no what is the practicals of EIGRP, what we have configured. Sorry, we have to just no router EIGRP 10. That's it. We have to just mention the command no router EIGRP 10. That's it. simple way, exit, show IP route. See this guys, entire routing protocol of EIGRP has been removed from our routing table. This is a simple command to remove the routing from the routing table. So we have to do for all the branches. So we'll move to the Hyderabad branch. You have to learn also troubleshooting also. That's why I'm not skipping this video. You should know how to remove the routing table also. So that's why I'm not skipping this video. Okay. Subnet enable subnet show IP route. Also config T IP routing. Then no router EIGRP 10. That's it. Exit. Show IP route. Clear? Previously it has the routing, right? Now the EIGRP routing protocol has been removed from our router. So like this we have to do all the branches. Subnet enable subnet show subnet enable subnet show IP route to check the routing table. So it is also not showing the routing. We just put the command show IP route. Clear? So now we are going to configure our today's practical, that is OSPF, configuration of OSPF. This is our practicals. So we'll configure from Chennai, okay, Chennai branch. We are going to start the configuration from Chennai branch. So what is the syntax here? This is our syntax for OSPF. Okay, config T IP routing, then router OSPF 10. We are taking process ID. Process ID also it is from starting 1 to 65,535, and the area ID also it is starting from 1 to 65,535. So this is the syntax we have seen just now. The syntax is what? The router OSPF 10, we are taking process ID as a 10 only. We are assuming it. We can take anything 1 to 65,535. We are just taking 10 as per example. So we have to take 10 to all the branches. Okay. So network 172.16.0.0 and the wildcard mask, right? We have seen the syntax. I will show the syntax. Okay. This is the syntax. Here based on the syntax we are doing our practical. See this IP routing, router OSPF, then we have to give process ID, then network directly network ID we have to give, and wildcard mask and area ID, then exit. This is the syntax. So this is directly connected network, and then wildcard mask of the class B is 0.0.255.255. Wherever is the 255 we have to just take as a 0, and wherever is the 0 we have to just take a 255. That's it. And area 0, enter. Then network 192.168.1.0, then 0.0.0 class C. This is the class C, right? So 0.0.255 into area 0, enter. That's it. Exit, show IP route. It will not show until unless we'll configure all the branches. Okay, that's it. This is a simple task, guys. OSPF is very simple. We have to do all the branches. Based on this we have to do all the branches. We'll move to the Hyderabad branch. This is the configuration of Hyderabad branch. This is the syntax. Okay, so config t, sorry, IP routing, router OSPF 10. Then we are giving network 172.16.0.0 and the wildcard mask. Then network 172.17.0 and the wildcard mask area 0. Then network 10 E0 we are taking, area 0 exit. Simple. See, this is the syntax of the Hyderabad branch. We have to configure based on our diagram only. Whenever we put the wrong command, it will stuck here. Okay, config t, then IP routing, sorry, IP routing, then router OSPF 10, then network 172.16. Here the see this here 172.16.0.0, then wildcard mask area 0, then network 172.17.0 wildcard mask area 0. Like this we have to put 16.0.0, then wildcard mask of class B is 0.0.255.255, then area 0, then area 0, enter. The network 172.17.0.0 class B wildcard mask 0.0.255. Sorry, network 172.17.0.0.0, then wildcard mask 0.0.255.255, area 0, enter. Then network 10.0.0.0, then wildcard mask 255.255.255.0, area 0, enter. Then exit and exit. Now Hyderabad branch has been completed. Now we are moving to the Bangalore branch. So this is the syntax of Bangalore branch. This is the syntax. So config t, IP routing, then router OSPF 10, enter. Network 172.17.0.0, wildcard mask is 0.0.255.255, area 0, enter. Network 192.168. 160.2.0 and wildcard mask of class C 0.0.0.255, then area 0, enter, then exit. Show IP route. See this. For OSPF, what is the abbreviation? It will represent O. See that. O is representing, right? This is how we have to configure the OSPF. So now we'll check whether our all the branches are pinging or not. Okay. So we'll start from Bangalore branch. We'll take a Bangalore LAN system and we will going to ping to the Chennai branch systems. Okay. Ping 192.168.1.1. 1.1. If it is pinging, then our practical has been completed. See this guys, it's pinging, right? So our today's practical is completed. We are going to ping to the second system of the Chennai branch. See this guys. We are going to ping the Hyderabad branch also. 10.0.0.1, sorry, 0.1. See this is pinging, right? See this guys, it's pinging. Moving to the Hyderabad branch, we are going to ping the Chennai and Bangalore branch. Ping 192.168.1.1. This is the Chennai branch. It's pinging, right? And 1.2 Chennai branch system 2. Then Bangalore branch 2.1 system 1 and system 2 series. 2.1 and 2.2. It's pinging, right? So today we have completed our class. So this is how you have to configure the OSPF. Now from coming videos we are going to learn the switching. So routing we have completed till now. From next videos onwards we are going to learn the switching. In the CCNA we have to configure routers and switches. So we have learned to till now how to configure the routers of the Cisco series and any series. So going forward we are going to learn the switches. We are going to configure the switches. Okay. So now we have completed today's class. So please guys like, share and subscribe to my YouTube channel and share these videos to your friends and relatives. Don't forget to press the bell icon to get the latest videos. Thanks for watching guys.